resistivity of a material of a given wire. In this experiment, we will find the resistivity of a given wire. To find its resistivity, first we will find the resistance, then we can find the resistivity by using the suitable formula. Principle behind the experiment is Ohm's law. So the law states that at a constant temperature and pressure, the potential difference across the wire is directly proportional to the electric current. V proportional to I, V is equals to Ri, where R is a constant of proportionality called resistance of the wire. R is equals to, the formula, R is equals to V by I. So if you know the voltage and current, voltage across the conductor and current through the conductor, we can find the R. So after finding the R, we can find the resistivity. Rho is equals to pi d square R by 4L, and this formula is derived by the factors that the resistance depends. R directly proportional to L and R is inversely proportional to area. So from that we will get resistivity. So resistivity is equals to pi d square R by 4L, where d is diameter of the wire and L is length of the wire. Both these two values are given, and the given values are sticked near the experiment. So since the D and values are known, so we need to find the value of R by the experiment. After finding the R, we'll put the value of R here and we can find resistivity. Now I'm going to explain the circuit diagram to find the unknown resistance. So to do this experiment, we required a battery eliminator, ammeter, voltmeter, a rheostat, plug key and unknown wire R. So here from positive terminal of the battery, take one wire and connect that wire to positive terminal of ammeter. From negative terminal of ammeter, take two wires and one is connected to resistance one end and one is connected to voltmeter, or you can take two wires here and one is to ammeter and one is to resistance. And from negative terminal of the voltmeter, take two wires, one is to another end of the unknown resistance and one is to upper end of the wire. From left end of the rheostat, the wire is connected to a negative terminal of the battery through a switch, plug key. Now let us perform the experiment. Let us switch on. So from positive terminal of the battery, the wire is connected to a positive terminal of the milliammeter. From negative terminal of the milliammeter, I have taken two wires and one is connected to resistance, another one is connected to voltmeter positive. From voltmeter negative, I have taken two wires, one is connected to unknown resistor other end and another one is to rheostat upper end. From rheostat left end to a negative terminal of the battery through a switch. Let us take the readings. So you can see here, by varying the voltage across this unknown resistor, the current also varies. As voltage increases, electric current in that wire is also increases. As voltage decreases, the current is also decreases. We'll take some readings and we'll find R by using the relation R is equals to V by I. First I'll set voltmeter reading for a 0.5 volt. I'm going to set this voltage value to 1 volt because 3 trials are enough. And you can see the current reading is 100 milliamps. So for 1 volt I'm getting 100 and I'm going to enter the value here. So for 1 volt I'll get 100. Similarly I'm going to increase it. For 2 volts I'm getting 200. So I have written here for 2 volt a 200. For 3 volt a 300 milliamps. To find the resistance in ohms, this current should be in ampere. So that is the reason. So here it is written as 100 into 10 power minus 3 amps. Calculations. R is equals to V by I. V is 1 volt and it is written 1 and I is 100 into 10 power minus 3 amps. It can be also written as 0.1. 100 into 10 power minus 3 is 0.1. 200 into 10 power minus 3 is 0.2. And 300 into 10 power minus 3 is 0.3. Now 1 by 0.1 is 10 ohms, 2 by 0.2 is 10 ohm, and 3 by 0.3 is 10 ohm. So for all the 3 trials, we'll get the value of R as 10, and we'll take average of these 3 by adding the 3 and by dividing the 3. So R average is equals to 10 plus 10 plus 10 divided by 3. For 4 trials, add all the 4 and divide it by 4. So we have done with 3 trials. So 10 plus 10 plus 10 by 3, which is equals to 10. So we have got the value of R. Now we can easily find its resistivity by using the relation rho is equals to pi d square R by 4L. As I said, D is a given, which is written here, 0.28 into 10 power minus 3 meter diameter of the wire, and the length of the wire is also given, which is 50 into 10 power minus 2 meter. And I'm going to substitute the value of D, L and R to this expression. The value of pi is 3.14 into 0.28 into 10 power minus 3 the whole square. Be careful here. So put bracket and put whole square into the value of R is 10 divided by 4 into the value of L is 50 into 10 power minus 2, or you can also write this as 0.5. 50 into 10 power minus 2 meter is 0.5 meter. Now after the calculation, so here first you square it. So 10 power minus 3 square is 10 power minus 6 and write 10 and multiply all the numerator values. So we'll get 0.2461 into 10 power minus 5, and in denominator we'll get 200 into 10 power minus 2, or 10 power minus 6 is there, so we will get this as 0.02461 into 10 power minus 6. Now after the calculation, we'll get resistivity as 1.23 into 10 power minus 6 ohm meter. So this is what the resistivity of the given wire, which is 1.3 into 10 power minus 6 ohm meter. So as the length changes, resistance increases, but resistivity remains same. So resistivity depends on the nature of the material and the temperature. So here we have assumed the temperature is constant, and the given wire resistivity is 1.23 into 10 power minus 6 ohm meter. Thank you.